It's part 10. We're still on neurotransmitters. And we just finished up with some molecules regulating mood. Now we're on to somatostatin. Somatostatin, again, is a gut-brain molecule. It is the direct inhibitor of growth hormone, pituitary growth hormone. It's produced by the hypothalamus, among other places, and it says so right here. And it's also produced in the gut region, and it turns off stomach activity. So it has some very direct effects. It's they say here it's often released with GABA, so it is a how shall I say, a calming agent. Gut-brain peptide inhibits growth hormone release. That's very specifically what it does, as well as act on the stomach for calming the stomach down, slowing the stomach down. CCK, also part of the gut program. It's the thing that turns on our small intestine, it turns on our liver, it turns on our pancreas. We release various enzymes into the small intestine as a result of this molecule. It does act within the brain, and so that's an important detail as well. But it is, let's come back here and make sure we're on the right level. There we go. Basically, it is involved in anxiety, pain, memory. A gut-brain peptide hormone inhibits appetite. Okay, so usually it's when the food is ready to leave the stomach, that and we need to shift from a pH of 2 to a pH of 8 in the small intestine. That's when we get the release of CCK. And it literally does cause the pancreas to release its enzymes and to pour out bicarbonate-rich fluid into the small intestine. ATP, an obvious molecule of interest here. Of course, it acts upon the pumping system and causes, how shall I say, activities. It increases the activity of cellular life. ATP released by sensory neurons, and then released also by injured cells. It provokes pain sensation, okay, when that's necessary. Pain is pretty important. Never underestimate the importance of pain. If you know where the pain is, then you know that you need to do something less, or you need to make an adjustment of some kind. So pain is a good thing. It's also, as one of my professors used to say, it is, you don't have pain, you have sensation. That was one of her her commentaries all the time. At any rate, it's good to be involved in sensation. Adenosine generally inhibitory. It's a second messenger molecule. It's throughout the central and peripheral nervous system. Basically, caffeine, and then other similar-like molecules. Theobromine from chocolate stimulates, is a stimulant by blocking brain adenosine receptors. Adenosine, actually, if we were to study sleeps, adenosine actually makes you drowsy, and it builds up across the period of a day. And caffeine actually clears the adenosine. So that's kind of interesting. Adenosine is supposed to be there by the time it's your bedtime. It's supposed to be present, and chocolate and caffeine get rid of it. Unfortunately, it's supposed to be part of sleep, and sleep itself, when it's done restoratively and well, actually clears the adenosine, and you're ready in the morning to start anew, as it were. So we'll have a video about that. Actually, it's going to be about Matthew Walker, a PhD psychologist at UC Berkeley, originally from England and Harvard, but is now with us here in the Bay Area, and he runs the sleep clinic at Berkeley and has much to say about adenosine. At any rate, it dilates arteries, increases blood flow to the heart and other tissues as needed. It's an important part of restorative sleep. Never underestimate adenosine. And then we have nicotinic Oxide, angel of the matrix, and I'm all set for this one right here. Here's an important detail I'll tell you. In anything having to do with metabolic syndrome, basically, when we have glycosylation products, we have plaques in the blood stream in the cardiovascular system. The angel, that is to say, if you get good sleep and exercise, what could be yours to be having is endothelial nitric oxide synthase, which then creates ENOS, which is endothelial nitric oxide. And what does it do for a living? It has positive protective effects. And basically it remodels your body, personally your body. So it changes all of your little clogged country roads and pathways into superhighways. And it promotes vasodilation of the vascular smooth muscle. So that means you're going to get more blood flow everywhere. It counteracts smooth muscle cell proliferation, and it's going to reduce basically hardening of the arteries and hypertension. It's going to decrease platelet adhesiveness, so much more flow through, decrease adhesiveness of the endothelial layer to white blood cells. It's going to be anti-inflammatory, antioxidant, scavenges reactive oxygen species, prevents cancer in that regard, anti-fibrotic. Okay, so, and then also it is a diverse anti-atherosclerotic action, so it prevents atherosclerosis. So this is a magnificent molecule. You decided to become a vegan one day and get 9 hours of sleep every night and wake up to a perfect meditation, and then you decided that you would go for a 5-mile run in the forest every single day under the beautiful sunshine, and you became ever more fit and wonderfully happy, and a large change in your body happened, and it was nitric oxide that was the mediator of all that. So I want you to kind of make that association. Okay, that's why I call it the angel of the endothelial matrix. Okay, so endothelial matrix is the connective tissue, the loose connective tissue beyond the basement membrane, wherever we have capillaries. Remember that we have 50 trillion mouths to feed. Isn't that a lot? You know, there's people who complain about having 3 children or 5 children or 8 children, but you've got 50 trillion cells in your body. And so you have meals on wheels. It's called the arteries, veins, and capillaries. And you're feeding everybody, all the 50 trillion, and you're getting rid of the waste products, so oxygenation, nourishment, and getting rid of all the naughty waste products. And so basically you're overcoming all kinds of problems with regard to Viagra. Actually, they discovered allows nitric oxide to flow in the region of the genitals and other areas of erection. And so erectile tissues could be in a number of places. And so that's part of the deal. Carbon monoxide is an excitatory, inhibitory type of thing, and we're going to be finding it in the brain and in certain neuroglandular places. They don't have any comments here on that, so it's not a widely used molecule. And then we have our cannabinoids, which are inhibitory throughout the central nervous system, involved in memory, appetite control, that sort of thing. I had a student once tell me that it's good to take cannabis because it already exists in the body, which is not a good argument, it turns out, because there's a lot of things that already exist in the body, like opiates. It doesn't mean you should have heroin, right? So, but at any rate, a comment is well taken. And so that's the deal right there. And then they go through a listing of different molecular types that can act within the neurotransmitter. So there could be peptides, purines, gases, and lipids. Of course, we have our nitric oxide just the way you like it. Lipids would, of course, be things like steroid hormones. Okay, so they will play a role in all of this. So we've basically covered a lot of territory here, and we now need to move on to this little idea right here, which we'll pick up in the next episode.